What's up, everybody? It's Dan from sagemathtutoring.com, and I have another amazing video for a student of mine who could use a little support and encouragement when it comes to percentage problems. And his awesome mom sent me this picture, and we're going to cover it. So let's take a look at what the picture is even saying. So it's giving this example, what is 70% of 250? Okay, so looks like they're giving two methods. And I actually like this. I like that the teacher is giving two methods because I think most students will find that they'll tend to gravitate towards one or the other, depending on their personality, maybe. But I'm going to sort of translate each of these because these look terrible. Like, no one wants to look at this. No one wants to deal with rate, base. I mean, it's all confusing. There's an R, there's a B. That's just terrible. We have a B, we have a P, a B, a percent, blah, blah, blah. So let's just analyze what is 70% of 250. I'm just going to take a look at that right now. So what I'm going to talk about is the first methodology, which is on the left, but I'm going to explain it in such a way that it doesn't feature all this gobbledygook. The truth of the matter is that when you're presented with a question like, what is 70% of 250? It's almost always the case that you can immediately translate the question into some kind of algebraic equation. Okay, so I like to refer to this as the direct translation method. So, first of all, whenever you see the word what, you should be recognizing that that's the unknown. So, therefore, that's going to be x. Anytime you see the word is, you should be recognizing that that means equals. All right. And if you think about it, it sort of makes sense, right? Is, it kind of means equals, right? Just in general. Whenever you have a percent, like a number with a percent symbol next to it, you're going to have to convert that to a decimal. The good news is that you could always just remember that if you're converting from a percent to a decimal, you just have to move the decimal place twice to the left. All right. So that's going to be this. Now, this next one is kind of weird. We have the word of, right? We have the word of there. Now, of, strangely means multiply. Now, I'm going to draw an asterisk because I want to make sure that this symbol is clearly differentiated from the x. So whenever I write an asterisk, just know that that means multiplication. And then, of course, we have 250. Now, 250 is just 250. Now, you might be wondering, okay, well, how did you know it was just 250? I mean, we turned that into 0.7 and we just left that thing alone. Well, actually, yeah, because anytime you have a number that's not like related to the actual percentage, then it's just itself. Okay, so anytime you have a number that's not the actual percentage, it remains itself. And as you can see, we just set up an equation that essentially guides our next step, where it's like x equals 0.7 times 250. So if we want to find out what x is, which is what we want to do, you just multiply 0.7 times 250, and that would give you 175. Boom. All right. So basically, in other words, 175 is 70% of 250. The fact that 175 is less than 250 makes total sense because if something is only, 70% of some larger number, well, yeah, it's going to be smaller. Okay. So that's the direct translation method. Now, obviously, I could immediately dive into this other method right here. But you know what I want to do? I want to hang out with this method for a while because there's two more situations you're going to have to deal with that are a little bit different, that still, feature usage of the direct translation method. However, before I talk about the sort of variations of this strategy, I'd like my student at home or whoever's watching this, I want to give you the opportunity to do this. I think it's one thing to like passively, sit here and watch and take it in, but of course, it's another thing to actually try it once you've learned it, right? I had a teacher once that said math is not a spectator sport, and even though that's an annoying teacherly saying, it's totally true. It's unfortunately true. So I'm going to give all of you an opportunity to do this kind of a variation right now. Okay, so the opportunity is here to do this. So go ahead, pause the video and try this one. All right, so hopefully you paused it. You might not have, but I will say the answer. I'm not even gonna do it because we gotta move quickly here. But the answer is 110. Hope you got it. If you don't know what happened, if you didn't get it, I'm not sure why, just review these steps and then try it again. So anyway, that is that variation. Now, like I said, there's two more variations where this strategy could apply. This says what is 70% of 250? The unknown was the part. We have the whole over here, and there's the part. But what happens when the percentage is unknown? What would a problem like that look like? Well, it would look like the following. It would look like this. Now, it actually has the word 7 written out, but let's not worry about that. Now the unknown is the percentage. So what we're going to have to do is the direct translation method. Now, the good news is there's a lot of sort of similarities with regards to what we just did. So let's just write 7, because like I told you, you know that if it's a number and it's not the actual percentage, you could just rewrite it, okay? Then we have the word is. So the word is, as we discussed earlier, that's clearly equals. We have what percent. In this case, let's use p. I'm going to use p as a variable. And in my opinion, that's probably the best variable to use. I know we used x over here. You know what? You might want to just use p when it comes to the percentage because you want a variable that reminds you that it's the percentage. And you're going to see why later. But just take my word for it for now. So now we have the word of, which is just going to be multiplication. And then, of course, we have the word or the number 210. So we have 7 equals p times 210. Now, at this point, it's just a regular old equation. So all you have to do is isolate p by dividing both sides by 210, right? Because that's how we isolate p. And of course, by doing that, we cancel the 210s, right? And then we end up with p equals 7 over 210, which is 0.03 repeating. Okay, so that 3 goes on forever, so it's like 3, 3, 3 repeating. Okay, so now, why did I choose to use the letter P as a variable? Well, I think it's probably going to be a good idea, if you're solving for the percentage and you're using this translation method, and only if you're using this translation method. It's a good idea to use P because then you can remind yourself that this is the percentage, which means there's going to be an extra step at the end. What is that extra step at the end? We pretty much made it to the end, but the extra step is you have to take this decimal and move it twice to the right. Now, obviously, before we took the decimal and moved it twice to the left. So when you're converting from a percentage to a decimal, you take the decimal and move it twice to the left. But when you're converting from a decimal to a percentage, you're going to have to move it twice to the right. So then you can kind of do that extra step, and it's going to become 3.3 repeating percent. So in other words, 7 is 3.3 repeating percent of 210. So let's have you try a similar problem right now. Okay, 5 is what percent of 30? Go ahead and pause the video, try it yourself. I'm going to give the answer in a moment. So the answer to that one is 16.6, repeating, and we should be thorough and write the percent symbol. So that's the answer to that one. If you're not sure how I got that, refer to the work above. Moving on to the third and final variation of what you can expect with this translation strategy. Here it is. So now we have 10 is 35% of what number? What's different about this variation? Well, now, before it was the part that was the unknown, and the larger number, which is the whole, that was known. Well, in this case, the whole, what usually is going to be the larger number, that's unknown, whereas the part is known. Okay. Keep in mind in the middle one, it was the percentage that was unknown. So all three of these are actually different variations. They can all be solved with the direct translation strategy, but they're different variations, right? Different variations. So bottom line is with this one, I think probably most of you could do this at this point. You're probably getting good at it. We got 10. We've got the word is, that's equals. We know we need to change this into a decimal if we're going to work with it, as far as working the problem out. The word of, we know, is multiplication, and what number in this case will be x, okay? We used x as the unknown before when it was just a regular old number, and we're going to use x right now when we have an unknown that's just a regular old number. We used p when it was the percent. Now, could I have used x there? Well, sure, but remember, I wanted to just use p because that could serve to remind me to do that final move at the end, okay? Now, I could have used x and just simply remembered to do that final move at the end with the decimal. But, maybe just get in the habit of using P. A lot of tests and a lot of textbook homework problems, they'll often use P for the percentage. So there is that too. Anyway, we've translated this third variation, and clearly all we have to do to solve for x is divide both sides by this 0.35. So that's what we had to do, 0.35. 0.35. We've got that, and then we have x equals, well, 10 divided by 0.35 is, we're going to say it's approximately, it's not exactly, but it's approximately, and I'm going to use these squiggly lines because when math people use these squiggly lines that sort of almost look like an equal sign, that's a symbol for approximately, okay? So I'm just trying to be precise by saying, well, it's not exact, but it's approximate, and it's going to be approximately 28.6. We're going to round to the nearest tenth. So that is that one. So in other words, 10 happens to be 35% of 28.6. All right, notice that 28.6 is larger than 10, and that's how it should be, because if 10 is only 35% of some other number, well, this number should be larger. Okay, so now I invite you at home to try a similar problem. Okay, 70 is 40% of what number? Go ahead and pause the video, try it yourself, see what happens. Go for it. Okay, hopefully you paused the video, or maybe you didn't, and it's just this awkward thing where now you're just going to get the answer, out of nowhere. So the answer is this. It's 175. Hopefully you got it. And if not, whatever. Just look at the work over here and apply it. So that concludes at least the direct translation strategy. But there's another strategy. If you recall this now tiny picture, the translation strategy is on the left, and then we have the other strategy on the right. So we're going to go to that. We're going to look at the other strategy that they talk about, and that is this sort of, let's see, that is this part over whole, percent over 100 thing. So we're going to disregard the gobbledygook mess over here. And we're just going to cut to the chase. This one basically says, here's a structure that you can literally always use no matter what. And in fact, I say that's probably what a lot of students like about this one. It's just like a structure that you can count on. And that is part over whole equals percent over 100. Now you might be wondering, really? 100? Always 100? And the answer is yes, always 100 down here. And when I say percent, I don't mean the decimal version. I mean the actual number of, whatever the percent is. So for example, if it was like 35%, well, you know what would go here? 35, because that's the percent. Okay, you don't put 0.35, you would put 35 here. All right, so that's important to sort of square away. I would say maybe if there is any difficulty when it comes to this strategy, it's about being super clear about what the part and the whole is. One decent rule of thumb is like, depending on the question, usually the whole is going to be like the larger number in the situation. But even that's a little shaky. Like every now and then, there's going to be a small percentage, no pun intended, of problems where the whole is actually going to be smaller than the part. And I know that's really weird. Don't think too hard about that. The structure is still going to serve you. The structure is still going to produce the right answer. But you do have to be careful. You have to understand, okay, what's the part, what's the whole? Okay. Well, in the case of the problem that they gave you, which is what is 70% of 250? I'm going to rewrite that again. So you're going to have to get clear on like what the part and the whole is here. I'm going to give you a nice clue that a lot of teachers seem to be fond of. I could say, well, the whole is what would, you know, be the larger number usually according to common sense. Okay. And that's not really reliable. All right. In fact, some of you probably wonder what the heck I just said. Okay. But what I just said is something that's not reliable. So don't even worry about it. What you might want to do is use the is over of thing. Okay. Now, this isn't mentioned in the workbook, but nonetheless, is over of, first of all, it sort of rolls off the tongue. Like is over of, it just rolls off the tongue. So is over of is part over whole. It's the same thing. Okay. So some teachers teach the is over of method, some teachers teach the part over whole method. And one way or the other, it's really the same thing. Okay. But if you can remember that part goes over whole and is goes over of, is over of. Now you might be wondering, okay, well, great. So I assign these weird words. How does that help? Well, it helps when you realize what is stands for and what of stands for, of course. What is stands for is the number that's to the left of the word is, like that. And of stands for the number that's to the right of the word of. Okay, when it's written this way. Okay, so if you have is over here and then of over there. So when it's written in this sort of standard question format like this, you can very clearly see that it's this like curly Q arrow thing that goes out. Okay. Now, why do I keep on harping on the standard question format? Why do I keep saying when it's written like this? Well, it might be written differently. You might have a word problem that's like 70% of 250 is what? you know, it's kind of up to you to sort of realize that that could be rewritten as what is 70% of 250. Okay. So if you hear some weird word problem that's like 70% of 250 is what, huh? Well, you could be like, okay, that's just another way of saying what is 70% of 250. In fact, I wish they asked me that way because it's a little bit easier to kind of think about instead of this weird sentence. All right. But this is like a normal looking question. What is 70% of 250? It's very straightforward. So is this number that's sort of connected to is, and it's not the 70%. Of is the number that's connected to the word of, and it's not the percentage. So in this case, it's is over of. And since the is word is what, well, that's going to be x. That's going to be the unknown. So it's going to be x over of, the of is the 250. So we're going to write 250. And that's going to equal the percent which they give you over always, 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 always 100. Now, we can do something called cross multiplication. I'm sure a lot of people watching sort of know how to do cross multiplication. You could totally do that now. But I'm a big fan of making your life easier. And one way to make your life easier is to reduce this, because 70 and 100, they're kind of big, clunky numbers. I don't really want to multiply 70 times 250. That would be miserable. So what I'm going to do is I'm going to just reduce this fraction to 7/10. Okay, so just imagine, crossed out the zeros, I divided the top and the bottom by 10, I reduced it, and now it's 7/10. In fact, just to avoid confusion, I'll erase that. I mean, it is 7/10. 70 over 100 is 7/10. Now I'm ready to cross multiply. A lot of students like to do this thing where it's like, wah, 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 like that. So if you like that, go ahead. Basically, that just means multiply this and put it on one side of the parentheses. So that's going to be 10x. And then we're going to multiply these guys and put that on one side of the, not the parentheses, the equal sign, I should have said. So 7 times 250 is 1750. And then if I divide both sides by 10, because I'm still trying to solve for x, right? Well, of course, that would cancel the tens, and then I end up with x equals. Now, I could use a calculator, like 1,750 divided by 10, and I could figure it out. Or I could remember anytime you divide a number by 10, you just take the decimal and move it once to the left. So that's going to become 175. That's the trick of the trade. Now, if you're not sure what I just said, just rewind it. You can move the decimal once to the left. That's all you got to do. Just remember, too, you can use a calculator or use long division. If you have to use long division, go ahead and use long division. But divided by 10, you just move the decimal once to the left, and then you have your new number. So we have x equals 175. That is the answer to that one. Now, you might be wondering, well, okay, great, but are there any other variations like that I have to worry about? And the answer is yes, okay? There are other variations you have to worry about. We're going to get to those, but first, I'd like you to try this one. You're going to say, or you're going to solve reading the, probably should have paused the video for that part. Probably a little awkward to hear that process, but please solve this one using the is over of method. Go. All right, 12. So if you got 12, good job. Unbelievable. All right, let's look at variations. You know what? I'm going to erase everything. I'm going to erase everything because we don't need all this. This is it's a big mess at this point, right? So now the question is the following. 30 is what percent of 75? Now let's keep in mind we are totally using the part over whole equals percent, the actual percent, over 100. We're also keeping in mind that's also sometimes teachers call that is over of. So let's get clear on what goes where. I mean, the is certainly the 30. The of is certainly the 75. And then we have this what percent. So that's actually going to be the unknown. Now I'm going to use P again. Actually, you know what? I'm going to use X this time. We're going to use X. So we're going to have is over of, though, on the left for sure, right? Because that's is over of. So we're going to put 30 over 75. Fine. You know what always goes here? 100. Always. So just put it there. And then we don't know what this is. Now I'm going to use X this time because we're not going to do a weird decimal move at the end. When you're using this part over whole deal, you don't have to move the decimal of the percent, okay? Whatever number ends up here, this number is the percent. I sort of talked about that before, but I want to reiterate that. Whatever number ends up here is the actual percent. So I'm going to put X because I don't need the variable P to remind me to do anything at the end, okay? So bottom line is we could cross multiply, or we could realize this is divisible by 5, this is divisible by 5. So we're going to reduce it. So we have 6 over 15. And what do you know? These are divisible by 3. Wow. Wow. So 6 divided by 3 is 2. 15 divided by 3 is 5. So we really did actually make our lives easier. I know it might seem like we didn't, okay? Because that was weird what just happened. But trust me, if you get good at reducing fractions, it makes your life easier, definitely. And here's why. Because look at this. We're going to bring it all the way over here. We're now dealing with 2/5 equals x over 100. Isn't that a lot better? I mean, yeah, you got to be careful over here, but once you do it, it's like, oh my God, thank God. So now we have this cross multiplication stuff, right? So clearly, it's going to be 200 because that's 2 times 100 equals 5 times x, which is 5x. Okay. Then you have to divide by 5. Fantastic. X equals 200 divided by 5 is totally 40. And that's the answer. Now, you don't have to move the decimal. 40 means it's actually 40%. So I'm going to write percent. It's actually 40%. So that's that one. Now, I'm going to give you an opportunity to do something similar right now. Please do this one. All right, 2 is what percent of 300? Please use the part over whole method and go. Now, what you would find with this one, after maybe using x as the variable, is that x equals 0.6 repeating percent. You might be wondering, but it's a decimal. How can that be? Well, sometimes percentages are decimals, okay? Now, I understand there might be some confusion here because you could be like, okay, but I thought it was supposed to be a percent, not a decimal. Well, sometimes percentages can be decimal. If I wanted to turn this percent into the decimal version of itself, the truth is that this equals 0.06 repeating. That's what we refer to as sort of, let's call it the official decimal value. Whereas this is the actual percentage. You still might be confused, and I understand that. Bottom line, just rely on the structure, go through the motions, and it's going to pump out the right answer. So that's that one. We're going to do a final variation, and then we're going to call it a day. All right, so we have 50 is 70% of what number? Let's do the is over of. Why not? Is over here. Of is over here. Look at this. Of is the unknown. So that's going to be x in this case. Nonetheless, is over of. So it's going to be 50 over of, which is x. And again, I'm using is over of, but remember, is related to the part, of is related to the whole. So I could also be like, the part is 50 and the whole is x. I could say it like that too. And then what goes here? Well, the actual percentage, 70. And that's going to be over what? 100. And then you can make your darn life easier. Chop off the zeros. I'll rewrite it over here this time. We're going to have 50 over x equals 7 over 10. Cross multiply. We're We're going to cross multiply that. We're going to cross multiply that. And then we end up with 500 equals 7x. Of course, we're going to be dividing both sides by 7. And, what do we get? We're going to get another approximation. So I'm making these problems up on the fly. So it's like you're going to get some ugly, weird answers. But the approximation is going to be 71.4. 71.4. And that's fine. Okay, so that's how you do it. All right. That's how you do it when it's the part that's the unknown. Or we could say the of is the unknown. Now, quick review. This says 50 is 70% of what number, right? You could have an annoying word problem that says 70% of what number is 50, right? That would probably be like unusual, but it can happen. And again, it's on you to rewrite the question in a way that's more direct. What the word problem is really trying to say is 50 is 70% of what number? All right, so I'm going to give you a problem that's kind of like that, all right, right now. Okay, 35 is 40% of what number? Go ahead, pause the video. Good luck. Let's find out how it goes. Oh, that's going to be, we're going to use x. X equals 87.5. Talk about a random number. Jeez Louise. 87.5. All right, so hopefully that was helpful to you guys. Again, two broad strategies. There's the direct translation method. Keep in mind the word of means multiply, if you're going to use that. And then there is the part over whole, also known as is over of method, which reliably works as well. So that's two strategies. And really, there's three variations for each strategy. There's the variation where the part is the unknown and everything else you know, and you have to find the part. There's the variation where the percentage is unknown and you have to find the percentage because you know everything else. And then there's the third variation where the whole is unknown and they give you everything else, and then you have to find the whole. Okay, so hopefully that makes sense. In a way, we just learned how to do 6 different kinds of problems. 2 broad strategies, 3 variations for each strategy. We just learned how to do 6 different kinds of problems. All right. So anyway, good luck to my student at home. And the time of recording is during the coronavirus, actually, for those of you watching this. So this is in 2020. And interesting times. It'll be interesting to see, people look back on this. And, I think everyone's like at home from school and stuff. So in a way, this video is something of a time capsule. So I don't know. It's kind of interesting. But anyway, good luck, and I will talk to you later. Bye.